Hello student, welcome to the last video of matrices. In earlier video we had started the solving the simultaneous equation by matrix inversion method, right? In that we had seen one example of two variable, two equations, right? How to find two variable x and y by using matrix inversion method. Now let's see one example of solving three variable with three equations. Okay, how to find three variables by using matrix inversion method. So in today's video we are going to see how to solve x, y, z, right? Three variables by using matrix inversion method. Now in matrix inversion method, what we have to do, first write down all the equation. So first equation is 3x plus y plus 2z equal to 3. Second equation is 2x minus 3y minus z equal to minus 3. And third equation is x plus 2y plus z equal to 4. Okay. After writing all the three equation in proper form means like this: ax plus by plus cz, okay, ax plus by plus cz equal to d. This is a proper form. Okay, all the variables should be in left hand side and constant should be in right hand side. Okay, so after writing all the equation properly, we have to convert this equation in matrix form. So matrix is Ax equal to B, okay, where A is a matrix of coefficient. So how to find this A matrix? So above write down all the variables. So first variable is x, second variable is y, and third variable is z. Okay. Now in first, second and third equation, what you have to do? You have to take the numbers, right? Only numbers. So in first equation with x, number is 3. In second equation with x, number is 2. In third equation with x, number is 1. So in first column, x के column में क्या आएगा? This numbers. So numbers are 3, 2, 1. Okay. Similarly, do this for y coefficient, y variable. So find coefficients of y, means numbers with y. In first equation number is 1, so 1. In second equation number is minus 3, so minus 3. In third equation number is plus 2, so here it is 2. Okay. Then coefficients of z. Coefficients of z, first equation coefficient is 2. Second equation coefficient is minus 1. Third equation coefficient is plus 1. So 2 minus 1, 1. Okay. After writing A matrix, next is x. X is a matrix of variable. So how to write this variable matrix? So write all the variables x, y, z variable in first column. Okay. So write x, y, z variable in column form. So x, y, z. Then B matrix. B is a matrix of constant. This B is a matrix of constant. So constant values are 3 minus 3, 4. Okay. So 3 minus 3, 4. So Ax equal to B. Ax equal to B. This much is clear. So first step is writing the equation in matrix form. Step 1 clear. Now let's see the step 2. In step 2, we have to find the A inverse, right? We have to find A inverse. Now to find A inverse, first we have to find the determinant of A. So here determinant of A is 8. Now since determinant of A is 8, that means determinant of A is not equal to 0. Means A is a non-singular matrix, right? Since A is a non-singular matrix, therefore A inverse exists. Okay, we can find A inverse since determinant of A is non-zero. Now, how to find A inverse? To find A inverse, we have to start with cofactors. So, cofactors of each element of matrix A. So, find cofactors of each element of matrix A. So, C11 means cofactor of element 3. Then C12 means cofactor of element 1. Then C13 is for cofactor of element 2. Okay. Then C21 is a cofactor of element 2. C22 is a cofactor of element minus 3. Then C23 is a cofactor of element minus 1. Then C31 is a cofactor for element 1. Then C32 is cofactor for element 2. C33 is a cofactor for element 1. Okay. So, after finding cofactors, how to find cofactors? For cofactor, first we have to write the sign matrix, right? So, sign matrix, first write the sign matrix starting with plus, then alternate sign, so plus, minus, plus, then minus, plus, minus, plus, minus, plus. Okay. Then cofactor of 3 means take the sign plus, then delete the first row, first column and find the determinant of remaining numbers. Okay. So, like this you have to find cofactors for all the elements. Okay. After finding cofactors, next step is writing cofactor matrix, means P matrix. P is a matrix of cofactors. So, from on the place of 3, on the place of element 3, we have to write the cofactor of 3. So, cofactor of 3 is minus 1. So, minus 1 will come in first place. Okay, in the place of 3, we have to write the cofactor of 3. Similarly, in the place of 1, what we have to write? We have to write cofactor of 1. So, cofactor of 1 is again minus 3. So, minus 3. Okay. Then, in place of 2, what we have to write? We have to write the cofactor of 2. Cofactor of 2 is 7. So, 7. Then, in place of 1, what we have to write? We have to write the cofactor of 1. Cofactor of 1 is 3. So, 3. Then, in place of 2, we can write the cofactor of 2. Cofactor of 2 is 1. So, 1. Then, in place of minus 1. Okay, let me clear this. Now, you can see in place of 1, what we have to write? We have to write cofactor of 1. Cofactor of 1 is minus 11. So, last number is minus 11. Okay. So, in place of all the elements of A, we have to replace this element of A by cofactor of that element. Simple logic. Replace this 3 by element of by cofactor of 3. Replace this 1 by cofactor of 1. Okay. So, after replacing this elements of A by cofactors, we get the cofactor matrix P. Okay. Then P dash, we have to find the transpose of P matrix, and transpose of P matrix is adjoint of A. So, find the adjoint of A means simply interchange row in column. Okay. So, by interchanging rows and columns, we get transpose of P matrix. So, after getting transpose of P means adjoint of P, we have to find A inverse. And for A inverse, formula is A inverse equal to 1 upon determinant of A into adjoint of A. So substitute determinant of A value. Determinant of A is 8. Then write adjoint of A. Adjoint of A is this matrix. Okay. So 1 upon determinant of A into adjoint of A matrix. Okay. Now, after this, what we have to do? We have to substitute A inverse value, okay, in equation. Which equation? Equation is x is equal to A inverse into B, okay, where A inverse, this is A inverse. So, A inverse is 1 upon 8 into this matrix into B. B is a matrix of constant. So, B is this matrix. Okay. Now, solve this. So, keep 1 upon 8 as it is and do the multiplication. So, multiply the first row with column. So, minus 1 into 3 will be minus 3. Then 3 into minus 3 will be minus 9. Then 5 into 4 will be plus 20. So, minus 3 minus 9 will be minus 11 plus 20. So, minus 3 minus 9 will be minus 12 plus 20. So, minus 12 plus 20 will be 8. Okay. So, first row, first column complete. Now, similarly multiply second row with column. So, minus 3 with 3 will be minus 9. Then 1 into minus 3 will be minus 3. Then 7 into 4 will be plus 28. Now solve this. Minus 9 minus 3 minus 12. Minus 12 plus 28 will be 16. Okay. So second row complete. Now similarly with third row with column. So third row with column. So 7 into 3. 7 into 3, 21. Minus 5 into minus 3. Minus minus plus 15. Minus 11 into 4. Minus 44. Okay. Now 21 plus 25 will be 36. 36 minus 44. 36 minus 44 will be minus 8. Okay. So after multiplication we get this. By solving this we get this values. Okay. Now 8, 16 minus 8 all are multiples of 8. So we can directly divide this numbers, this elements by 8. So 8 ones are 8, 8 twos are 16, 8 ones are 8. Okay. So after multiplying this we get this matrix. Okay. Now left hand side is capital X. Capital X is a matrix of variable. So capital X is a matrix of x, y, z. Okay. Now by equality of matrices, matrix are equal means all the elements are equal. So x equal to 1, y equal to 2 and z equal to minus 1. Okay. Clear? So for 3 by 3 matrix, same rule. For 3 variable, 3 equation, same rule. Rule is first write the equation in matrix form, Ax equal to B form, right? Then find A inverse, right? To find A inverse, first find the determinant of A, then find the adjoint of A, right? Then A inverse will be 1 upon determinant of A into adjoint of A. Okay. Then Last step is x is equal to A inverse into B. Okay. Do the calculation, then you will get this type of answer. So by equality of matrices, you will get the value for variable x, y and z. Okay. So class, here is some questions, right, which you have to solve this simultaneous equations by using matrix inversion method. Okay, then answer is given. So just check your answer in the next slide. So answer for first is 2 and 1. There is only 2 variables and 2 equations. Okay, in second equation also there is only 2 variable and 2 equations. Okay, in third C is again 2 variable with 2 equations, and last fourth and fifth 3 variables with 3 equations. Okay, x, y, z, and there are 3 equations. Okay, so first A, B, C is 2 by 2, D and E is for 3 by 3. Okay, so solve this and you can check your answer. Your answer is given in next slide. Answer for A, B, C, D and E. Okay, so with this I am completing the chapter matrices. So thank you.